So hi everybody, my name's Cristin, and I'm very excited today to talk to you guys about exploring portable, accessible HPC through open source. So a little bit about me. My name is Cristin Merritt. I'm with Alcesflight, and in January, I became the Chief Marketing Officer. I have been with Alces and in the world of HPC the exact same amount of time, 7 years this August. Prior to this, I worked in enterprise IT. I did some SAP, a bit of finance, but my dirty secret is that I actually have a humanities degree. I was a classicist studying in Roman archaeology. Don't ask, it's a long story. But the short of it is if anyone's interested, the ancient world is actually becoming part of HPC, so search out digital humanities. And you're going to see some really cool projects that are happening today in bringing the ancient world to life for the modern world. So I'm here representing two incredible groups. First, the company I work for, Alcesflight. Alces is Latin for moose. When people ask me, what is Alces? I often say it's the glue that holds the supercomputers together. So we are what is called integration and managed service specialists. We basically build and maintain physical and virtual high-performance compute clusters. And when I say virtual, I do mean private cloud and public cloud for customers all over the world. 3 fun facts about Alces. Fact number 1, we're 15 years old. Fact number 2, we are platform agnostic. That means that we have built hardware and on cloud across many different vendors. I'm pleased to say we have a lot of really good relationships with tier 1s, a lot of good relationships with software vendors, including some people who've recently joined like HPC Now and others. In fact, they're in the back, and they actually gave Alces our first start when we became a company to sit on their booth in the back corner showing them our wares. The other group, and actually the whole reason I'm here, is women in HPC. I'm so excited you guys like my shiny stickers. Women in HPC was founded 10 years ago at the University of Edinburgh, and what's it focused on? Equity in HPC. Originally, it was about women. Now we realize more and more it's about a lot of underrepresented groups. So if you want to join, anyone can join. It's free. Head to womeninhpc.org. On the right-hand side, there's a membership button. If you click that, you put in your details, you will also notice there are chapters and affiliates. And I'm pleased to say that if you're in the Barcelona area, there is a Barcelona chapter at the Barcelona Supercomputing Center, so by all means, please join in. Right, that's a bit about me. That's a bit about Alces, the fabulous women in HPC. Main event. OpenFlightHPC. This is a project I'm very excited to present on because I got to launch it 4 years ago. For those with incredibly good vision, there is a mission statement up on the board. The short of it is, it's all about simplifying general HPC adoption. Even the shorter, get users onto HPC system running fast. Now, why, Cristin? Would a commercial company such as yourself, why would HPC get into open source? Now, some of you in the room know straight out of the gate why this happens, but I think a little background to kind of connect the dots, because anyone who's going off to ISC after this is going to see a lot on sustainability. So let's talk about where all this stuff came from. In 2009, I know everyone can read this who's in the room, when Alcesflight came about, we always had flight components. Why did we have flight components? Platform agnostic. We realized very early on that if we locked into any particular hardware or software, we would be putting ourselves and our clients at a potential disadvantage. So we've always had open source around, and now you're going to see the wonderful history tick up on this screen really quick. But the short of it is, in 2015, the HPC community in the USA adopted a reproducibility initiative. No more could anyone really have these sort of standalone bits of research. If you were going to publicly produce HPC research for consumption, you needed to be able to move it about from machine to machine. In 2015, it was also when public cloud became what I call viable for high-performance computing. It'd been around a while. I'm sure they could have done it before, but this is really when that kind of like rush came in. So it was a big time for kind of change within our community. And at the same time, we launched our first version of what eventually became OpenFlightHPC, learned a lot from that. And in 2019, OpenFlight became an actual fully-fledged production-ready project. And I got to do a 6-foot-tall poster in Dallas about it that I'm very excited that is larger than me. 2019 was a good time to launch a big open source environment generation tool because 2020 came the pandemic. And we found out that with a lot of the shortages with different hardware bits and pieces, that people needed to have different tool sets to get different work done, especially those who were interested in expediting COVID-19 research. So what we did was we began to spin up environments across whatever resources we had. Physical hardware, cloud, sometimes in a hybrid scenario. In fact, both of the COVID-19 projects we did used a home cluster and public cloud to get their work done as fast as they possibly could. In 2022, Flight Solo came along, and that's one you can download, kind of bypass a lot of what I'm going to show you today. But what is today about? It's about sustainability, right? So let's draw the line. We had the idea of reproducing it. Okay, I can reproduce it now. How do I maintain that long term? And we're talking from a hardware, a software, and a power level. So this has been coming, this sustainability wave has been coming a long time, and that kind of leads me into what I call the 3 pillars of OpenFlight, and there's also 4 tenets. What are the 3 pillars, Cristin? Well, we need it to go fast, so time. We need it to be cost-effective, money, and we need to actually be able to do this. I refer to myself as the lowest common denominator. If I can use OpenFlightHPC, so can you. So in short, rapidly deploy resources. If I can rapidly deploy them, and we just had this big conversation, reduce the costs, right? How can I spend more of my money on research over spending my time carefully crafting and loving upon my cluster? Because OpenFlight comes from a public cloud kind of project where it really came to life, we know all about the fact that it can cost the moment you turn the switch on. And the last bit is about standardized components with flexibility. So, and I'll get to this in the tenets, it's a lot about I can do this straight away with very little guidance, or I can go in and make this a bit more crafted, a bit more my own. 4 tenets of OpenFlight. Number 1, we will endeavor to always make sure it is platform agnostic. This is because, again, this is the Alcesflight way, so this will be the OpenFlight way as well. Number 2, and you're going to see this in some videos that I'm going to show real fast about how it kind of expedites the process. We want to take down as many barriers as possible to getting more people into utilizing high-performance computing. Out-of-the-box functionality, again, you'll see it shortly. The idea of I select a few things and away I go, but also the flexibility to change out things if I need to get my job done. Who uses OpenFlightHPC? I'm pleased to say the first adopters were our researchers. This goes all the way back to when we were just doing this on public cloud. They got a bunch of credits, which still come out now and again from AWS and Azure and Google, and they're like, what do we do with these? And so they started building up ephemeral environments, and the next thing they did was portable containerized environments. You heard, if you were here yesterday, a lot about Kubernetes. A lot of educators love the idea of creating something separate which they can teach their students which the system administrators do not have to mess with, which they love. They don't like, oh, we got to do this for the school and get them out there. And they grasped onto this, took it, and said, R&D, fantastic. We've got something now that people can play with, and we don't care because it's not careful, crafted. What we had also happen, and this happened at the University of Liverpool, was business continuity, digital twinning kind of stuff. University of Liverpool keeps their cluster on-premise, but guess what? They had to move it. What do you do You cannot just, okay, everybody, down tools, 2 weeks, we got to move this cluster and make sure it goes fine. Instead, they did a critical infrastructure revision. They figured out what resources they needed, built them an OpenFlightHPC environment on AWS, and for those 14, well, actually it was 10 days, now that I'm thinking about it, they ran critical research on public cloud. New system went in, cloud went away. Finally, and kind of like the overlay, we're seeing a renaissance in like the idea of private cloud as well with the larger systems. So people like the fact that they can partition that out and give their researchers everything they need to get going. Right. This is a risk. So everyone, you're coming with me on a journey. I have spent time with our team, and we have recorded some real short snippets of OpenFlightHPC in action. You are going to see me go from configuring or composing an HPC environment to an actual simulation running. So all of this, by the way, is in documentation on openflighthpc.org. It's also, we're going to have like a shortened video where it's a little bit longer than what I'm about to fly you through, if anybody wants to replicate what I'm doing up here. Right. The idea, again, of out-of-the-box components. And I know in some of your minds, I know there's been a conversation about easy build. So there's a point here where I'll say, guess what? If you don't want to use ours, easy build will slot in right there and do your deployments. Real quick, external network, virtual network, head node, and 2 baby compute nodes. So again, this is actually a cluster that we regularly spin up when we do education work for some of our customers. So it's very basic. All of the instructions for actually bringing one of these up, again, openflighthpc.org. We've got our services. There's 6 of them. One I'm going to spend a lot of time on, SSH. User Suite, the Flight Web Suite. We're going to spend a lot of time here during this demonstration. Queue system, a very important thing called storage, and the user management itself. So in your minds, as we go through, if something that you utilize slots in better, slot it in your mind better. Again, the idea of getting everything out of the box or changing it to what you want it to be. Woo, step 1, let's compose ourselves an HPC cluster. All right, so I need to SSH into this system to get going. The simple fact is the first bits we wanted to do was reducing barriers by making it as easy as possible to set up an HPC, or to compose an HPC environment. So I know everyone can read this. I'm hunting down my resources right now. I'm Flight Hunter Parse, and I'm going to label them. I'm going to label a login node, and I'm going to label my 2 compute nodes. The next thing I'm going to do, and this got me really excited when I saw this, was profiling. This used to be a huge amount of setup, and now what we do, if I can get this to pause, do you see down here? We have a drop-down. Jupyter, Kubernetes, Slurm multinode, or Slurm standalone. If you do not want to mess with and you want to get going straight away, you just literally arrow down and select what you want. So I've done that. I'm going to do a multi-node cluster, again, because I have 2 little baby nodes. And then I'm going to answer, I think, another 6 questions where I establish the cluster name, demo2. I'm very creative. And I'm going to give myself a username, a password, and an IP address, pausing there really quick, demo2.cloud.openflighthpc.org. I'm going to copy and paste that later so that I can use my web suite. Now, everyone here is fairly experienced in the wonderful world of high-performance computing, but we have learned in the past that sometimes it's nice to watch all your profiles get set up correctly. So we do have a visual for this. It's a bit silly, but I know I like seeing it, especially if a wonderful thing called a red X shows up, so I know something's wrong or if something's right. So very quickly, I'm going to watch everything get set up. You see these little green ticks here. So you're actually watching it, if you'd like to see it all set up. I will now leap forward in time because I am the controller of all time and space. And oh my gosh, it's done. Look at that. So everything's now complete. For my login node, I now need to apply the same profile to my compute nodes. Well, actually, I need to do the compute node profile to my compute nodes. In this case, again, nothing special. I just want to make these things run. You will say, potential question, Cristin, that's kind of neat. Can I make a profile and save that profile and use it later, bypass all this stuff? And the answer is, it is in progress. It was actually, as soon as it was shown to me, I went, and they went, yeah, we know. You want to save a profile. So they're going to get to that, but it is in progress. This is way down from when I first started, and we were looking at like 15, 20 minutes to try to set stuff up. So again, I'm jumping ahead in time, and I'm going to check really quick that everything is complete and all is running. I have now just composed my HPC environment. So what happens next? This is the accessibility side. If I'm a sysadmin and I want an end user who has all fear in the world of what I just did, I need to set them up a desktop session so they can get running, right? So here I go, copying that demo2.openflighthpc.org for those who can read, and welcome to the Flight Web Suite. The first thing I need to do is log in using that flight username and the password. And just for funsies, I'm going to mess up my password here so we can all watch the fact that, I was too excited, I suppose, that day. And step one, did my environment actually do everything I wanted it to do? I'm going to launch a terminal really quick and to do kind of a sanity check, as it were, to make sure that the resources are there. You really can't read this one. But the short of it is, yes, it worked. So once I know that something's worked, now I'm going to set up my desktop session. So in the corner, teeny tiny, you're going to see a drop-down that says desktop. I'm headed over to my desktop session. Wow, Cristin, that is a lot of white space. That means multiple desktops can be launched. In fact, we did do this initially because we were doing classes for some of our clients, and we needed to control and find out if someone was messing up something or they needed to have a new desktop session launched. So yes, you can have multiple up. This comes with GNOME, standard out of the box. If you want something else, please, by all means, change it out. This is me just doing a quick sanity check that everything that I wanted in a desktop session is going to be there, but I'm headed to the files. I cheated a little bit. Remember what I said? Flexibility. You can either do it straight out of the gate, or you can make it a little flexible. Well, I'm doing a demonstration for you all today. I'd like it to be pretty, or at least visually stunning. I'm not a CFD engineer. However, OpenFOAM and the motorbike simulation is a really good way to make sure that I've gotten the message across. Although I am, again, not a CFD engineer. So I want to modify the script in motorbike because I don't actually know when this little workflow finishes. And I also want to speed it up a little. So I've just gone into the file manager and I've picked the motorbike.sh script. Going to do a quick edit in here in which I kind of speed the plow a little, as well as put in the word beginning and finished in order to know that actually what I've just done is actually taking place. So here I go, zooming ahead just a little bit again, but you can kind of see me say echo.beginning and there'll be an echo.finished. And once that occurs, I'm going to go ahead and save and be done with it, which is going to happen now, poof. And just like that, I've gone ahead and set everything into position where, if I was maybe a sysadmin, I would throw it over to the user and say, install your software, run your stuff, I don't care. But let's just say that I wanted to teach someone how to do this and go all the way to the end. So, done my accessibility. Now I'm going to do my software installation. Many guys here just watched the whole a little bit of chatting about easy build. So in your mind, delete what I'm about to show you, insert easy build, and away you go. There's something in here. In a minute and a half, I'm going to install OpenFOAM. I love this. And anybody who has gone through compiling hell loves this. When I started out with OpenFlightHPC, there was someone who came up to me and he says, but can it run? Can it run? And I went, sure thing. And I went to the URL and I grabbed everything and I started compiling and I went, can you come back in 2 hours? And so they went off, they came back, and there it was, and they played with it, and that's nice. I was on a show floor in a conference room, so Wi-Fi dependent, as it were. But the team came up with a thing called Flight Silo. What's Flight Silo, you ask? It is the 5 most popular open source applications our users kind of get a hold of, generally because they're in a position to where they want to train people how to use them. So we have Bowtie, Hadoop, Jupyter, Kubernetes, and OpenFOAM. I'm almost there. So voila, I'm going to go ahead and I'm going to install OpenFOAM. I'm going to zip forward in time because this part's boring, but the short of it is it's going to have a thing that says it's running. It's there. I'm a happy bunny. Let's move on and run our workflow and get our results, shall we? Once again, you're probably going to be like, wow, Cristin, why do we have to keep going in and out of the web suite? This is because we actually recorded these things assuming that people might walk away and come back as they kind of go through this education so that it's not like hurting them, like, oh, where was I? Again, we record to my level of intelligence on HPC. Let's just put it that way. So nice and big. Here we go. Let's run our little motorbike simulation. So I'm going to copy down motorbike. I'm going to get my little script, and away we run. I did do some minor modifications here because this is a Slurm cluster. And after I make my little run things done, I've done my partitions, and I'm going to get that underway. SQ. We are off and running. Oh yeah, I kind of need to get my results out. That would probably be a good thing. 5 minutes pass rapidly within a blink of an eye. And you see that word? Finished. So I now know what I just did and what I just edited is actually done. And I can actually move on now and see the results. Back we go again into the desktop session, and I'm going to bring up Parafoam. So once again, for those who are thinking, wow, okay, I can go take my little engineering class on this journey and launch multiple desktops, yes, you can. So I think this is where I mess up. Anyone who is not a CFD expert but gets to run the OpenFOAM stuff, I mess up ParaView and Parafoam like all the time. So the short of it is I am pulling down my results. I am going to launch it, and voila. Oh, actually, so we are, by the way, the motorbike simulation is a standard simulation that OpenFOAM includes. So what you see here is what they teach as well. And in this case, they tell you to check all the boxes and then uncheck 5, and you get a little guy on a motorbike. So I think I've got 2 more to uncheck. I'm running up against the wall here. Voila, apply. And just like that, I got a little guy on a motorbike, which I'm going to zoom into now. This is all about wind resistance. Obviously, red means lots of wind beating against your motorbike. And on the other side, we have all the light blue, which is where kind of the wind is passing us by. So, just like that, I have composed an HPC cluster environment, and I've gotten all the way to the end to a user running an environment. If you want to be involved in OpenFlightHPC, openflighthpc.org. The cluster build methodology is all in there, so all that stuff that happened prior to me launching a cluster. In fact, that is not my expertise. Oddly enough, working for an integration company, they put me out on the end user side quite a bit. We've got Flight Solo, which can be downloaded or subscribed to on AWS, and all the tools and workflows we saw today. Women in HPC, once again, please join us. Everyone is welcome. In fact, at the last 2 large global events, 20 to 50% of the audience was male, and they were all there to talk about how can we be better allies in this space. If you're headed to ISC, we're going to actually have OpenFlightHPC environments up and running. So if you're coming and you actually want to play with it, make yourself root, break it, install whatever you like, by all means, come by the Alcesflight booth. Women in HPC, if you're holding an exhibition class or greater, you can go and see all of the Women in HPC events, including an exhibitor forum takeover, the poster session, and we have some incredible early career speakers. Elizabeth over in the corner will be speaking, so you can come and see her as well. Questions?
Thank you so much.
I think I ran straight up against the wall there, but I wanted to show everybody all the stuff. It's really fun.
Okay, questions? Well, I have one.
Okay.
So probably you haven't covered this. Well, you haven't covered this in the demo.
Yeah.
But the first question I rise to my mind is, what about elasticity? So is there any elastic kind of plugin in a Slurm that shoot down all the machines
so
when
if you want to set like your parameters for how big or how small you can get, you 100% can do. I was just showing you the I just want to go version of this so that everyone could kind of get what we in America would call a whistle-stop tour of everything you see. But yeah, you can set your parameters about what kind of, how big or how small. This also connects, if this kind of goes to the commercial side, this also connects to some of our tool sets where we can actually, on a commercial element, if you say, cut me off at X, we can actually cut people off. And we can also look at budgetary range, but again, commercial side of things, not so much the open source.
So, okay, so there is a pro version or an enterprise version of
well,
that, or additional software that you add on top of that?
I wanted very much to show the stuff that anybody could get a hold of today. But yeah, you can change it, and it's all in the documentation on OpenFlightHPC.org.
Awesome. Thank you so much.
Sure. Anyone else?
Questions?
So thank you very much for the presentation. It was awesome. I would like to know, can some of the components of OpenFlight be deployed on its own? So for instance, the flight UI, it looks nice. So I want to just have that without all the other provisioning and
yes. So we work with, like I said, this whole thing is production, and we have customers who have very much, they like the OpenFlight UI, but they don't want anything else. And it can be what we call like chopped and changed. Again, you just saw like the world's fastest demo, and if you want to do the swap outs, it is in the documentation because we've already changed out a few things for other people, and when we do that, we document it for the open source project as well. Ooh, ooh.
Sure.
You actually smiled at me the whole time, so you should have one. Everyone else is like, ooh. Yeah.
Hi, Cristin. So you stated you're a commercial company. So what's your business model?
I'm sorry. Your immersion business. I only heard part of it. Can you do it again?
Yeah, you stated Alcesflight is a commercial company.
Yes, we are.
So what's your business model? How do we
do this? So I kind of alluded to it when I said there are commercial aspects that we wrap around the OpenFlight environment. We have a tool set called Alcesflight Center where we centralize and manage components within an HPC cluster. People can customize what amount of management we place on top of things. Some people want nothing to do with the administrative side, the boring day-to-day side of their cluster. Other people want control over certain aspects. A lot of people really like to look after their own queue systems, but that is where we kind of get the engagement. We learned a long time ago that trying to keep the software kind of sacred wasn't doing us any good in order to be able to grow a lot of our clients who started out very small, and everything, as you know, is getting bigger. And especially now with a lot of people wanting to move to multiple locations or have hybrid. So where we step in commercially is being able to manage all that for them if they want to.
Thank you.
You want a moose? You've asked a question. Okay. I'll give it, yeah. I only have two. Woo! This one's mine. Sorry.
Okay, no more questions then.
Yeah, it's all right. Thank you guys so much. I would say
it was a joke. If you have any more questions,
you can come see me at lunch as well. Go ahead.
About the storage.
Storage. You said the storage, the S word.
Yeah, I saw that the demo. It's great and it moved, but one of the mains is the data. What is the data and how we move the data with our cluster? And where is
okay.
the data located?
So yeah, I kind of glossed over that because again, this is like the little trial. Can you see it? It all works, sort of thing. Storage can be configured and established before. Like I did the drop-down profile. we're not doing a drop-down profile anymore. We need to go back. We need to set up your profile the way that it works for you. And that's why I went, as soon as I saw that, someone's going to come to me and say, I have a specialized storage system. I need to move my data so-and-so. Being able to save that, I'm looking forward to when that's done. But yeah, it can all be configured, again, all in the documentation. But the short of it is, what I bypassed a lot in the early profile stages, that's where we would get that connected up.
So is the solution cloud-centric? So it's purely cloud?
It is based on cloud. So it started in public cloud, but we use it on bare metal, we use it on private, and we use it on public now. So it has the cloud methodology as its base. I think a lot of people within the HPC community have embraced the methodology of cloud, not necessarily public cloud, private cloud. They like that idea of portable HPC. They like the idea of being able to set something up and take it away as quickly as possible.
Awesome.
Oh, look at that.
Exactly about
microphones everywhere. Go
exactly
ahead.
about the cloud. You mentioned something just about AWS, but
Yes.
the company plays with all the tiers one.
So I want to kind of talk a little, if you want, and again, I see them setting up food, and I don't want to hold you guys back too much. So the public cloud is the domain that I was actually hired to join Alcesflight in, because I, with an enterprise IT background, do not care about hardware. I'm so sorry to all of you who care. I got in so much trouble when I first started out, like skipping in with my cloud methodology, and they were like, you know, get ye back, Satan. And the thing is we've worked with AWS, Azure, and Google. Our most recent projects have been hybrid-based. A lot of people have their on-prem cluster, but then they need to get a hold of resources very quickly. So AWS was used to move Liverpool. AWS was used on the, you guys saw Mare Nostrum yesterday. We did an education project for part of the Comp Biomed team. That was used to do how to teach bioinformaticians about what HPC is. We've worked with Azure on both our COVID-19 projects, because they had very quick access to a lot of GPUs, which a lot of people couldn't get at the time. And we've worked with Google on a cool little project at Sterling University where they were trying to figure out if they could map water quality. So they needed multiple resources. It all had to be compiled into a centralized hub and sent off for processing. So friends with all, as we put it, and hardware-wise, same thing. I personally have worked mostly with AWS, Azure, Dell, and HPE, but our team has a much longer experience than I do with HPC.
Okay, thank you so much.
Thank you.